So position is where an object is located, but displacement is different. It's the change in position. Or delta x, which would be x final minus x initial. Now, remember, distance is simply how far. No direction, just how far. So we'll keep this little note here. Now let's look at a position line. We'll say x is 0 here. And over here, this is where x is equal to positive 2. And this is where x is equal to negative 2. And let's say we have a person that starts at negative 2 meters. And that time is 0. And then the person moves to x equals 0 at 1 second, and x is equal to 2 meters at 2 seconds. And if we mark where they are, we can collect this as our data for time and position. So at t equals 0, our person was at negative 2 meters, at 1 second, at 0 meters, at 2 seconds, at 2 meters. This is the information from our dot diagram. Now we can graph it on a position time graph. So let 0 position be in the middle, and we'll label negative 1, negative 2, and then positive 1, positive 2. Then our time goes from 0 to 2 seconds, so we'll need to include 1 second and a 2 second, equally spaced. Now I'm going to plot my points. My first point is at t equals 0, and position is negative 2, and then at 1 second, 0. At 2 seconds, we're at positive 2. Draw a straight line through the data. Now speed would be distance over time. And this little dude moved from negative 2 meters to positive 2 meters. So the distance is 4 meters. And the time was 2 seconds. Therefore, the speed would be 4 meters divided by 2 seconds, or 2 meters per second. Now the change in position is a different calculation. It should be the change in position is the final position minus the initial position. Delta x equals x sub f minus x sub I, and my final position is positive 2, and my initial position was negative 2. So 2 minus a negative 2 gives us 4 meters, and the slope of a line in general is rise over run. So in the case of our position time graph, we'll have a change in position the slope will be the change in position over the change in time. So the slope is the rate of change of position. and it tells us how fast and in what direction the particle was moving, or the object was moving, or the person was moving. So we know they go from the negative side to the positive side of our line. So we know that they're moving in the positive direction. This is a big deal. So the slope is not just the speed, but it is the velocity, which is a special quantity, a vector quantity, because velocity has a magnitude, which is just a fancy word for number, and it has a direction. Now the direction can be however you define it. It can be up, down, left, right, positive, negative, but a vector is an important type of quantity. And so the slope of our position time graph is velocity, which is not the same as speed, because velocity can be positive or negative. It can be up or it can be down. It can be left or it can be right. Just depends on how you define your situation. So for example, let's look at a position time graph where we have an object that starts at an initial position of 4 meters and at t equals 0. So that point is 0, 4. And then later at 2 seconds, we're at negative 4 meters. So connecting those dots, I can find the slope of that line, which is the velocity, because this isn't a distance time graph, it's a position time graph. So it's the change in x over the change in t. So therefore our velocity, use a script v for the velocity, would be negative 4 minus 4, so final position minus initial position. And negative 4 minus 4 is negative 8. 2 minus 0 is 2, and so we get negative 4 meters per second. So the negative sign tells me which direction it was moving. So moving in the negative direction in this case. Maybe the negative direction is down, maybe it's left, maybe it's south. And then the 4 tells me how fast it's moving. It's moving at 4 meters every second.